All right, everybody, section 10.5 is a pretty tough one, but let's see what we can do on this one. So this one really goes back to what we did in section 10.3, where we were finding the area of regular polygons, but now it moves on into the tougher ones. The three nicer ones that we did in 10.3 were equilateral triangles, squares, and regular hexagons. Those ones are nice regular polygons because when you create the triangle, which came from drawing your apothem and a radius, it always formed a special right triangle. That is not going to be the case always, and so today we're going to do three examples of ones where that does not work out so nicely. So let's start talking. First of all, we have a pentagon here, and a side length of 921 feet is given to us. By the way, if that sounds like an odd size just to randomly choose here, the reason why is because there is really one pentagon that people tend to know, and that is the Pentagon in Washington, D.C., where our government's military is headquartered. And the Pentagon, as the name would imply, is a pentagon, and each side of that building is 921 feet. So anyway, let's get rolling here. Because we're talking about a regular polygon, we still are going to use our formula here that we used in 10.3. Area of a regular polygon is 1/2 times its perimeter multiplied by its apothem. In step 2, we fill in what we know. Area is equal to, we've got a 1/2. Now the perimeter is not known, and neither is the apothem, so there's a lot of work to be done here. But the perimeter is going to be the easy part. To come up with the perimeter, we have to take our side length here of 921 feet, and we're going to multiply that by the number of sides that we have here, which is 5. So our perimeter here is going to equal, I'll do this with you guys. Here we go. 921 feet multiplied by 5 gets us a perimeter of 4,605 feet. So 4,605 is our perimeter, and that's going to go right here. 4,605. Okay, now that wasn't too bad, but the apothem's going to be a little bit tougher to come up with. So to do our apothem, we're going to locate our center point, which I'm going to guess it's not too important. It's located right about there. We draw the apothem, which comes straight down to the bottom side here and is perpendicular to it. So that's your apothem. And even though we don't really need it, I'd like to go ahead and draw the radius here to that vertex. I like to draw this radius right next to the apothem here. Okay, so with that in mind, this little red triangle that we have here is pretty important. The first thing to note is that we do know the length of one of the sides in that triangle. This piece right here to right here that I'm coloring in blue right now is half of one of our 921 foot side lengths. So I'm going to go to my calculator, take 921 and divide it by 2, and that gets me 460.5 for this piece right here, 460 and a half. The next thing we're going to have to do is figure out the angles within that triangle. So this angle right here becomes really important. Now the way we find that, and this is probably going to look familiar compared to what we did in 10.3, to find that, we're going to have to figure out theta, the measure of one of our central angles. So to do that, we always took, to get theta, we always took 360 degrees and divided by the number of sides that we have. So that 360 divided by 5 is going to get us 72 degrees. Now that's the measure of one central angle. So from radius to radius, this angle here we're saying is 72 degrees. But the angle that we want right down here is half of one of those central angles. So if we take 72 divided by 2, that gets us a 36 degree angle right here. 36 degrees. And now what we see is that unlike the triangles, squares, and hexagons we were dealing with in 10.3, this triangle we have in red is not a special right triangle. It's not a 30-60-90. It's not a 45-45-90. And that, unfortunately, everybody, means that we're going to have to do some trig in order to figure out the length of A. So I'm going to switch colors yet again. I'm going to go to red with this one here. And let's start setting up a trigonometric equation to try to use this 36 degree angle to figure out A. Okay, A here is going to be the adjacent leg to this 36-degree angle, and the 460.5 is all the way across the figure. That's the opposite leg. So if we think back to SOHCAHTOA, the trig ratio that uses adjacent leg and opposite leg is tangent. So this will be the tangent of 36 degrees, and that equals opposite leg of 460.5 over the adjacent leg of A. Now, we don't like this situation here where the variable is on the bottom of the fraction, so this is when we flip-flop these two. And we're going to get A is equal to 460.5 divided by the tangent of 36 degrees. And that, as ugly as it is something we can type into our calculator. So 460.5 divided by, here we go, the tangent of 36 degrees. Gets us an answer of 633.82. So I'll write that down, 633.82. As I look at the diagram, I'm pretty sure that my apothem here had to be longer than this leg, so I feel okay about that answer. 633.82 for the length of our apothem. And boy, this is a mess, but now that we have everything, we know our perimeter, we know our apothem, we're ready to go to step 3 and to go ahead and answer the question. So 1/2 times our perimeter of 4605 times our apothem of 633.82. So 0.5 multiplied by, the perimeter was 4605, and the length of the apothem was my previous answer here. So I'm going to go ahead and hit answer so I don't have to type that number in manually here. And we get a very big number of 1,459,379.471. I think we can probably round, well, I usually like to round to the nearest hundredth. So 1,459, 1,459, 379.47. 379.47. Everything was measured in feet here, so this area is going to be in square feet. Okay, and there's our answer to that one. So these problems are not easy, you guys, and they take up a lot of room, so be aware of all that. I'm going to skip this example with you right now because really the same information was given to you here as in the last problem. You know a side length, and I wanted to do a couple different ones. I'm actually going to jump to what is example number 4 right here, a dodecagon. We'll do this one, then we'll come back and we'll do number 3. I think this would be a better order. Okay. So in this problem, we have a dodecagon, and if you remember the name, the do kind of sounds like dos from Spanish, which means 2, and deca means 10. So in a dodecagon, we are dealing with 12 sides. Okay, that's a 12-sided figure. And in this piece, they gave you the length of your apothem here, which was 22 centimeters. And we've got to try to figure everything else out from there. So here we go. Step number 1, area of any regular polygon is always going to equal 1/2 times perimeter times apothem. Step 2, fill in what you know. Area is 1/2. We do not know our perimeter, but we do know that our apothem right there was given to us as 22. So we've got to try to figure out our perimeter. Now to do that, it's kind of one thing at a time here, guys. What we really want to find first is this little piece right here on the bottom that makes up half of a side. So I usually call that X. So to do that, we're going to make this triangle right here by drawing a radius. So there's R. We have our apothem here. This leg is 22 centimeters, and we've got to try to figure out X. So, once again, finding the measure of a central angle is key. So, theta is 360 divided by n, your number of sides, which in this case is 12. So, 360 divided by 12 means that we have 30-degree central angles. And that means that the angle that we're looking at, the one right here, is always that central angle divided by 2. So that is a skinny little guy of 15 degrees. I'm going to have to write that outside of the triangle and put an arrow right there. That's a 15-degree angle. Okay, and now I think it's going to be time to just set up and solve some trig here. If we want to figure out x, we're looking at a 15-degree angle, so you're standing right here. The 22 centimeter side is the adjacent leg. X, again, is the opposite leg. So once more, this looks like a tangent problem. So we're going to get the tangent of 15 degrees is equal to the opposite leg, x, over the adjacent leg, which is 22. And this setup is actually easier than what we did on the last problem. X is being divided by 22, so we just multiply both sides by 22 in order to get this to work out. And we're going to get x equals, and here we go, 22 tangent of 15 degrees. So let's try it. 22 tangent of 15 degrees gets us 5.89 for x. So 5.89 goes right there. Now, that, if I look at the relationship here between the x and the 22, I think that's correct. But we're not quite done yet. What we were looking for here was perimeter. And we're 2 steps away from figuring that out. Now that we know x, we're going to find s, our side length, by simply multiplying 5.89 by 2. Okay, a side length is an entire side right here. From here to here, it's going to be 2 of those x's. So, to try to keep things as accurate as possible, here we go. Remember that 5.89 isn't exact, so I'm going to hit answer times 2, and that tells me that one side length is 11.79. And then to find P, the perimeter, we take the length of each side, which is 11.79, and we multiply that by the number of sides you're dealing with, which again is 12. So this should be in the neighborhood of about 140, I think. So that 11.79, I hit answer, multiplied by 12, and that got me 141.48. 141.48. Okay, and that's our perimeter, everybody. So we'll put that here, 141.48. And now we know everything we need to know. So let's go to step 3 and let's type it all in here. So our area is a 0.5 multiplied by my perimeter, which was my last answer, times our apothem, which was given to us as 22, gets us a big area here of 1556.25. 1556.25. Things were given to us in centimeters, so this is going to be square centimeters now for the area here in number 3. All right. So, tough stuff. This is what it looks like when you're given the length of an apothem. And the third case I wanted to do with you here was a nonagon. And in this case, that 15-inch side that was given to you right here, well, we'll see in just a second what that's going to be. So let's go ahead and let's write out our formula. Area of a regular polygon is equal to 1/2 times perimeter times apothem. Let's fill in what we know for step 2. Area is equal to 1/2. Well, we do not know our perimeter, nor do we know the length of our apothem. This 15 that was given to us, when I go ahead now and draw an apothem coming straight down here like this, that's A. This piece down here on the bottom is going to be X. What they gave you for the 15 here was actually the radius. And the radius doesn't directly fit into the formula at all. It's not the perimeter, nor is it the apothem. So we've got work to do on this one. All right, we've got to figure out both of them. And because I think this is going to get messy, I'm going to go ahead and I'm going to start a new slide here, and I'm going to redraw what we just came up with right there, guys. We had a triangle that looked fairly tall and skinny like this. Our radius was equal to 15. This was A, and this was X. All we know is that that's a right angle right there. But that's as much information as we were given here, is that one radius was 15 inches. We've got to figure out both A and X. First things first, we've got to figure out theta. So theta is 360 divided by the number of sides that you're dealing with. In a nonagon, everybody, count them up if you need to, we're dealing with 9 sides. So 360 over 9 gives us a 40-degree central angle. Then for our angle, we always take that and divide it by 2. 40 divided by 2 is 20 degrees. So that's the angle that we are dealing with right here. Okay, with that in mind, we can find either x or a first. It's really about the same amount of work. We're going to go ahead and find x first. So with you standing right up here at the 15-degree angle, x is your opposite leg, and 15 is your hypotenuse. So think SOHCAHTOA, opposite leg over hypotenuse is the definition of sine. So I'll do that right down here. So it's going to be the sine of 20 degrees, and that equals your opposite leg, which is x, over your hypotenuse, which is 15. Not too bad of a setup. To get x by itself, we just multiply both sides by 15. Those 15s cancel, and do this to the side here. We're going to get x is equal to, and I just need to type in 15 times the sine of 20 degrees. So 15 sine 20, and that gets us an answer of 5.13. And as I look at the setup here, I find that fairly realistic, 5.13. Now, while I'm at it, we now know what x is. Let me go back to the diagram right here. So this piece is 5.13. Okay, eventually, we're trying to find perimeter here. Can't do that without finding side length first. And S is an entire side down here, so we take x of 5.13 and we double it. Multiply that by 2. And even though I can tell that looks like it's going to be 10.26, I want to keep this as accurate as I can in my calculator. So I'll do last answer times 2 and get 10.26, but now I have it as a decimal there. Okay, so where am I here? 10.26 for a side length. And now for perimeter, we take each side length of 10.26 and we multiply that by the number of sides we're dealing with. And again, in a nonagon, n is equal to 9. So I will take my last answer here, the 10.26, unrounded though, multiply that by 9, and get this pretty accurate answer of 92.35. 92.35 for the perimeter. So now we know P, and we'll write that number right below it, 92.35. Okay, we now need to find the apothem. So let me go back to this page right over here, and I'm going to switch to red in order to do this. Okay, to set up an equation for the apothem, from your vantage point right up here, the apothem is your adjacent leg. You still want to use the 15, which is your hypotenuse. So with sine, cosine, tangent, adjacent leg over hypotenuse is the definition of cosine. So the cosine of 20 degrees is your adjacent leg, A, divided by your hypotenuse, which is 15. Well, just like on the last one, our variable's being divided by 15, so we'll multiply by 15 on both sides. Those 15s cancel, and we're going to get A is equal to 15 times the cosine of 20 degrees. And that gets us 14.10 if we were rounding that. 14.10, rounding to the nearest hundredth. Okay, that's all we needed to do there for A. 14.10 goes right here. Okay, now the only slightly tricky thing here, and this is not something I'm going to nitpick too much with you guys on, is the following here. We actually have not one, but 2 rounded decimals in this setup right here. So you really want to take advantage, if your calculator has this capacity, and mine does, not to type in those numbers because they're not exact. I want to try to get my previous answers. So let's see what we can do here. I've got to take for my formula a 0.5 times that 92, and I think can I just click that? Let's see, on Texas Instruments calculators, I can go up. Nope, that did not work here at all. So, okay, unfortunately, I am going to have to type that in by hand. 0.5 times the 92.35 that we had for our perimeter. multiplied by our apothem, which was 14 and that was going to be 10. And that, about as accurate as I can with this calculator, is going to get me this answer of 651.07. 651.07. Everything linear was given in inches, so that's going to be square inches for that area there. All right, guys, 10.5 is a tough section. It's going to be a short homework assignment going along with it, but let's see what we can do. Good luck, and let me know if you guys have questions.